After knowing the algorithm, pseudocode, flowchart, now we will come to C. So, let us see what is the history of C. C is a procedural programming language initially developed by Dennis Ritchie in 1972 at Bell Lab of AT&T Lab. So, you can see Professor Dennis Ritchie, he was the one who developed this C programming language. It is referred as the mother of all the programming languages, because the operating system itself is written in C. C will never become obsolete. It was mainly developed as a system programming language to write the Unix operating system. So, initially, this was the purpose of writing C language. Now, let us see the evolution of programming languages. In 1960, ALGOL came into existence. This was given by an international group. In 1967, BCPL, it was proposed by Martin Richards. 1970, there was a programming language named B. It was founded by Ken Thompson. In 1972, C came into existence. It was founded by Dennis Ritchie. 1978, K and RC, means Kernighan and Ritchie founded C. There is a book by K and RC, you can just refer that, it is a good book. 1989, ANSI C came into existence. This was proposed by ANSI committee. 1990, ANSI or ISO C, this was given by ISO committee. 1999, C99 came into existence, that was given by the standardization committee. 2011, C11 was proposed by the standardization committee. So, this is from code4win.org. The source is taken from code4win. Now, standardization of C. As we saw in the diagram, in 1972, C was created as an evolution of the B language. In 1978, the first edition of the C programming language by Brian Kernighan and Dennis Ritchie was published, solidifying its popularity. So, C became popular in 1978. 1989, the ANSI C standard was established, leading to widespread adoption. In 1999, the C99 standard introduced several new features, including inline functions and variable length arrays. Today, C remains one of the most widely used programming languages, known for its efficiency and portability. So, this is the history of C. Now, let us see why C is so popular. So, coming to the features of C programming language. C is fast and efficient. It is known for its modularity. So, we call it as modular program or structured program. The entire program is broken down into tasks, that is sub-programs, and then it is been solved. So, it is very popular for its modularity and it is statically typed. That is the data type, it allows C static data type, and it is a general purpose language. Rich set of built-in operators, we are going to discuss that shortly, and libraries with rich functions. C has very rich libraries. It is a mid-level language because it communicates with the operating system. It also has a high level language. So, it is also a high level language, it is a mid level language as well, because it communicates with assembly level, and it allows portability, easy to extend, it is a procedural language. So, these are the features of C programming language. Now, let us see the structure of a C program. So, we have the preprocessor directives. As I showed you in the first program, hash include stdio.h, just like that all the preprocessor directives or the header files, they are written at the top. Then comes the global declarations. If there are any variables which have to be accessed across the different functions, we keep them as global variables. So, we do all the global declarations just below the preprocessor directives. After that, we have main. So, for main, the return type is optional. If you say main, by default it is going to take int, that is integer. There is a open parenthesis, there is a open brace, closed brace. So, main, open parenthesis, closed parenthesis, open brace, closed brace. Within this we have the local declarations, then comes the statements. So, this is the structure of a C program. If this program is having functions, so outside this main we are going to have the function bodies. So, function 1, open parenthesis, closed parenthesis, open brace, closed brace, here we have local declaration and the statement. Similarly, we will have up to function n, open, closed parenthesis, open, closed brace, within this local declaration or statements. So, this is the general structure of a C program. Now, let us see the structure of a C program. A C program involves the following sections. The first one being documentation section. Here we can just say what is the purpose of writing this program, what it is going to do and all that. Say if you are running a software company, one programmer has written a code. If he switches the company, the same code should be taken over by the other person. If you have a proper documentation written, it will be easier for the next person to take over. So that's the intention of having a documentation section. Next one would be preprocessor statements. This comes under the link section. As I mentioned, say hash include stdio.h. If we are having any string functions, then we invoke string.h. Or if we are having any mathematical functions, then we invoke mat.h kind of functions, statements. Next we have global declaration. Global declaration is if there are any variables which should be accessible from different functions, then we keep them as global. Then comes the main function. This is a mandatory part of in any C program. In any C program, we must have the main function. And one more thing is, we should define only one main function for one program. We can never have two main functions. Then we have the local declaration. Within main function, we will have the local declarations which will remain local to only the main function. After that, we have the program statements, expressions, everything. Like if at all we are having any other user defined functions, we keep them outside the main function. We can have any number of user defined functions. Now let's see the structure of a first C program. This /*// this shows a comment. Whenever we have multi-line comments, we use this syntax. Then we have hash include stdio.h. This is a preprocessor section. Then we have int main. This int is optional. We may write it, we might not write it. So this shows it is a main function. Then we have open brace, closed brace. We are just going to write a message, hello world. So print f, f stands for file. We have open parenthesis, closed parenthesis, within that the set of quotes. So the message is hello comma world. /n, this is called as a escape sequence which will take the control to the next line. Return 0, this takes the, this returns the control with a value 0. Since we are telling int main, we are returning a value 0 here. So this is a simple C program. Then let's see how to write the comments in C. So comments in C, they are used to add explanatory notes within the source code, making it more readable and understandable for the humans. As I said, if at all we have to write what the particular block of code is doing, we write that in a comment section. The C compiler, it completely ignores comments during compilation, so they do not affect the program's execution or size. This is very important. Whatever you write within the comment section, it is not translated by the compiler. Whenever compiler sees a comment, it will just ignore and then it will move on to the next line. So if you make spelling mistakes, if you make grammatical mistakes, compiler doesn't care. It will just ignore. Yeah, there are two types of comments. Single line comment, multi-line comment. So if we have double /, these show single line comment. Anything written after double slash on the same line, this is considered as a comment. They are typically used for brief notes or explanations of a specific line or a small section of code. If we just write like this is a single line comment. After that we have a declaration int x equal to 10. So we are going to declare a variable integer x. X is a variable of type integer and we are going to initialize that x with the value 10. So everything is done by this single line. After that we have a semicolon which shows the statement has ended. Yes, what are multi-line comments? When the comments run to multiple lines, then we are going to use /***. So this shows a multi-line comment. Any text between these symbols, including across multiple lines, this is treated as a single comment. They are suitable for longer explanations, documenting functions, or temporary commenting out block of code. Say we have written multiple blocks of code. For time being, we do not want one block of code to be executed. Then what we do? We comment it out. So we start with the /*, then end with //. That entire block of code has been commented. The compiler is going to ignore that block of code. So you can see this. We have started the comment here. We have ended the comment here. Within this, you can write any message. Yes. Now let's see the escape sequences. So any escape sequence, it starts with the /, and the escape sequences, they are written within the double quotes. Okay. So /A, this could be an alert or it could be a audible signal. Whenever the compiler encounters a bug or something, we want to end or we want to terminate the particular code, then we can insert /A. /B is backspace, /T is a tab, /N is a new line, /V is a vertical tab, /F is new page, or we call it as a form field. Slash R is carriage written slash question mark. So this is a wild character. If at all whenever we want to insert a question mark, then we have to precede that by a slash. This is a question mark. If we want to insert a slash, then that should be preceded by one more slash. So if at all we want to show backslash, we are going to write 2 backslashes. And this is a single quote, this is double quote. Then we can use octal constants, we can use hexa constants. To show an octal constant, we use slash O. Slash X is for hexadecimal constant. So this is about the escape sequences in C. Now let's see the white space characters in C. Slash B, as we saw in the escape sequence, it is a backspace. Slash T is horizontal tab. Slash V, vertical tab. Slash R, carriage written. Slash F, form field. Slash N, new line. So we had a set of all escape sequences. In those escape sequences, we have just separated out the white space characters. These are used exclusively for including the white space, but this white space is ignored by the compiler. So whether we give a white space or not, the compiler doesn't care. It is for us, for the users, to format the output beautifully, and this is used for better readability of the program. The compiler has nothing to do with the white spaces. It is totally going to ignore them. The files used in a C program. Okay, so now let us do a little bit of deep diving into C. The files in a C program, they are divided into source file. This is the one which the user is going to write. Then the header file, as I said, it is ended with .h, stdio.h, string.h, math.h, etc. Then the object file. When we compile the program, the compiler is going to create an object file that will be in the assembly level language, which is understandable by the machine or the computer. We will not understand. It is only the compiler which can understand the object file. Then comes the executable file. Usually in C it will be like, if it is a DOS platform, we will have .exe file. If you are working on Linux or Unix, it will be ./a.out. That is the executable file. Once you compile the source file, finally we will get the executable file if there are no errors in the program. We will take this executable file and then we are going to give input to this, we will get the output. So we are going to use this executable file after the process of compilation to run the program. Yes, overview of compilation and execution process. What exactly happens when we compile a program? So this is just an overview of it. We have a source file which we are giving it to the compiler. The compiler creates the object files, okay, that is connected with the linker. The object file and library file both put together is given to the linker, which will generate the final executable file. So this is the process of compilation and pre-processing before compilation. So assume we have a main program or a main function. We have one more user-defined program or multiple user-defined programs. How actually the compilation take place? Now let's see the pre-processing before compilation. We have source files, we have library files, both are given to the preprocessor. After that, the output of this is given to the compiler. The compiler creates the object files. These object files along with the library files is given to the linker, which will, the output of this is given to the executable files. Now let's see what is modular programming. As I mentioned, breaking a whole problem into smaller tasks is called as modular programming or structured programming. So given a modular program, how exactly the C compiler is going to handle it? The process remains the same. The source file and library file, both are given to the preprocessor. That output of the preprocessor is given to the compiler. Compiler output is given to the object files. Now the same thing, assume this is with the main program, this is with the user defined program. The same process, the source files, library files, it is given to the preprocessor. The output of this goes to the compiler output goes to the object files. Then all the object files along with the library files, everything is given, the output of everything is given to the linker. The output is going to the executable files. So this process is what is happening in the modular programming, the complete compilation and the execution process. Now let's see what are the C tokens. C tokens, they are the basic components of the C program. The tokens in C, we have the keywords, variables, constants, strings, special characters and operators. So this is how the tokens in C are segregated. There are 32 keywords in C language. Let's see one by one. So we will have a glance what each keyword is meant to do. Auto, this is a type. If the variable is automatic, then we say it is auto. Break is a statement which is used to break us out of some control statement. It could be a loop or it could be a switch. We want to come out of the structure when control, whether it is a loop, we will use a break statement. Cases, within the switch we will be having multiple options. We call them as case. Char is a data type which shows a character data type. Const, this is used for constant. Continue statement, if at all in a loop we want to continue with the next iterate value, we use this continue. Default, in switch, if none of the case options work, then we go for a default statement. Double is a data type, else we use it with if else structure. Enum, this is again a data type. We are going to assign numbers to each of the if at all there is a set, then a set of values we give value, that is enum, we say if it will be starting from say 0, 1, 2, 3, so on like that. Then extern is again a data type which is the variable would be defined outside of a function. We call it as extern. Float is a data type. For is loop. Go to statement, it will show where to send the control. Int, long and register, all these are data types. Return, it is a statement used to return the control. Short is a data type. Signed is a data type. Size of, this is used to check the size of a operator, say size of int, size of char. It is going to show how much of memory is used by the particular data type. Struct is used for structure. Switch, whenever we have multiple branching, we use the switch. Type def, it is going to define a type. Usually along with the structure we use type def statements. Union, this is one more derived data type. Unsigned data type. Void, we show this with the functions. If we are not returning anything, void means null. A function is not returning anything, we call it as void function. Volatile, after the execution we are not going to save it, it gets volatile. Do while, so it is used for a loop. If is a conditional statement. Static is again a data type, that is if you say static int, it is going to be initialized only once but the later values it will be, updated, but initialization in static is done only once. Coming to while is again used for a loop. So these are the 32 keywords used in C language. Coming to basic data types. Now, if the data type is character, keyword is char. Size in bytes, it is only 1 byte. The range is -128 to +127. The use is to store the characters. So integer is the next data type. The keyword used is int. Size in bytes 2. The range is -32,768 to +32,767. It is used to store the integer numbers. Floating point, the keyword is float. Size in bytes 4. Range is 3.4 e -38 to 3.4 e plus 38. To store the floating point numbers, then data type is double, keyword is double. Size in bytes 8, and this is the range. So void is valueless, size in bytes 0. The range is again 0. And one more thing we need to know is C is case sensitive. So this double is different from this double. Here D is capital, here D is small. C treats both of them as different. Okay. Now, detailed list of data types. Here I am just going to give you the detailed list. You can have a look at it. Format specifier is something which I would like to mention. For character, we use %C. Unsigned character, signed character, everything is %C. Int is %D. Unsigned int, %U. Signed int, %I. Short int, %HD. Unsigned short int, %HU. Then signed short int, %HD. Long int, %LD. Unsigned long, %LU. Signed long, %LD. Float, %F. Double, %LF. Long double, %LF. And the ranges are given over here, and size in bytes is also given here. Character consumes 1 byte, integer consumes 2 bytes, long int is 4, double is 8, long double is 10 bytes. So this much of memory is taken by these data types to store the values. Now let's see what are variables. A variable is a quantity which keeps changing the value during the execution of the program. Say integer I. It means I have declared a variable integer. I have declared a variable I. This is of type int. Now whenever I say this is the location, memory location. Say I am going to store a value 10 in this. Its location is say 1000. Whenever I say int I, integer consumes 2 bytes. So this is 2 bytes of memory. For the variable I, the compiler is allocate 2 bytes of memory. And the starting address of that is say 1000. Every time you run a C program, the memory location would be different. Say now it has been stored in 1000. Next time it might be stored in say 10,000 or maybe some location, 20,000, any location like this. Okay. So this is what is the meaning. If I say int I equal to 20. So what I am going to do, I have declared a variable I, which is of type int, and I am going to store a value 20 in that. So it means to say this is the location which is being allocated by the compiler. In that I am going to keep a value, or I am going to store a value 20. Its location is something, but totally it is 2 bytes. Okay. So as I said, the variable, it could be numeric value or it could be a character variable. Say if I say character C. So I have declared a variable of type character. Character consumes 1 byte. Say if this is C, I am going to store a value A here. So within C, I have stored a value A, which is a character. It is stored in memory location, say 2000. This memory location keeps changing. Now declaring the variables. So I have given some sample declarations here. Int emp underscore num. Say I am going to declare one employee number. It is of type int. Float salary. I have declared a variable salary. It is of type float. Char grade. Say the grade can be A or B or C or D. Okay, it could be anything. I am just going to say char grade. Double balance amount. Say I am going to check your bank statement. The balance amount would be double. Unsigned short int account number. Say in your bank, I am going to check the account number. The account number, it will not be a negative value. That is why we have used unsigned short int, because long int might not be necessary. If you are going to check for a small company, you might not have some 65,000 employees. Say it is having some 100 or 200 employees. So in that case, unsigned short int would do. If you are looking at a very huge bank, then you might need a long, unsigned long or whatever, depending upon the number of, if we are talking about employees, yeah, definitely employees would be shortened. If you are thinking of customers in a bank, that might be huge. So depending upon the value you are going to store, decide what is the data type which you need. Now, after seeing how to declare the variables, let's see how to initialize the variables. Integer employee num, which is equal to 10. So we have declared integer employee num. We have initialized that to a value 10. Float salary. Why float? Because it is going to have the decimal part also. So 1,34,876.50. That is the reason we have kept it as float. Char grade. See, when you declare a data character grade, you are going to put this in single quotes. Anything in single quotes, you call it as a character. Anything within double quotes is a string. Okay. So string. If you want to write anything, say for example BMS, it is having multiple characters. We are going to show that within double quotes. Then double balance amount. So you are going to, this is your balance amount, which is of type double. Then unsigned short int account number. If you want to initialize, you can say that value something is equal to 1, 2, 3, 4, some value. Okay, unsigned short int account number which is equal to some value. This is how you initialize the variables. Now let's see what are constants. So constants in a C program. Constants in a C program is divided into 4 types: integer, floating point, character, string. So let's see each one of it one by one. integer constants, say some value is stored in some variable, say integer a equals 1, 2, 2, 0, something like this. So this is a integer constant. Floating point constant, this will have a decimal point. This is having the integral part, you have a decimal point, then we will have the decimal point. So character constant, anything within single quotes we call it as a character. Say small c within quotes, small a within quotes. Now coming to this is not the number 6, this is integer 6, but if we write this within quotes, this is taken as character 6. Then we have string constant, anything within double quotes we call it as a string. So this is hello is a string constant, and we know this is always null terminated. So this is about the constants.